Good morning, good afternoon, good evening, depending on your respective time zones. This is statistical and geospatial inside YouTube. We are meeting again in lesson number 26, which is about application of standard normal distribution in hypothesis testing by comparing the Z statistics. By the end of this lesson, you'll be able to apply the standard normal distribution to the test hypothesis by comparing the calculated test statistics value to a critical value. Followed from the previous example in lesson number 25, hypothesis was formulated as follows. The null hypothesis states that the new medication has no effect on blood pressure, which means that the sample mean is equal to the population mean. And the population mean is denoted by mu, which is equal to the sample mean, which is equal to 140 millimeter of mercury. On the other hand, the alternative hypothesis states that the new medication lowers blood pressure, which means that the sample mean is less than the population mean. In this case, 140 millimeter is less than the mu. Please, you have to note that this is a left tail hypothesis because the sample mean here is lower than the population mean. In the previous example, in lesson 25, uh, the calculated Z-score was minus 2.636. The minus sign here tells you that this Z-score is actually lower than it is below the mean, which is 0 in the standard distribution curve. Okay, using the significance level alpha of 0.05, we're going to get the Z-score which is associated with this alpha. To get this one, we have to go and find it from the table of Z distribution. So this is the table of Z distribution. You come and then you look for the probability, your alpha level of 0.05. This is the alpha level. You see that this alpha level does correspond to a Z score of minus 1.6. It is below the mean, which is 0 here in this case. Now, you proceed upward. You'll find another number here, 0.04, and this is the probability associated with your alpha level. So we're going to add this 0.04. We add this 0.04 to 1.6. When you are adding, you are not considering the minus. So because I told you that the minus sign tells you that your Z score is below the mean. So now, having added this 0.04 to 1.6, you will get a Z score of minus 1.64. Now, let us come and see how do we do the decision that will let us to, to fail to reject the null hypothesis. To fail to reject the null hypothesis means to accept the null hypothesis or to reject the null hypothesis. As a rule of thumb, based on the magnitude of the Z-score, in the case of the Z-score which are above the mean, that is the positive Z-score, the null hypothesis can be rejected when the calculated Z-score is greater than the critical Z-score, because when the calculated Z-score is greater than the critical, means that it's falling directly in the rejection zone here. However, the situation is different when we are dealing with the left tail hypothesis. You know that in the left tail hypothesis, the Z-scores are negative. So here in this case, when to reject the null hypothesis in the context of the Z-score in the case of the left tail hypothesis. In this case, The null hypothesis is rejected when the calculated z-score is smaller than the critical z-score. Now our critical z-score is minus 1.645, which is the critical z-score of the alpha level of 0.05. This one is greater than the calculated z-score because now our calculated z-score is falling within the rejection zone. For this reason, we have sufficient evidence at the 0.05 significance level to conclude that the new blood pressure medication significantly lowers the mean systolic blood pressure compared to the general population. Thank you to follow. Please subscribe to the YouTube so that you get uh, the new videos whenever they are uploaded to the channel.